50 million years ago, a hungry land animal seeks a new source of food. This sets him on a spectacular evolutionary journey and on a collision course with rivals. Today, this creature looks like a fish, but it retains key traits from its terrestrial past. It's warm-blooded, a mammal, and it breathes air through its lungs. How did a creature built for land become master of the oceans? Asia, Pakistan, the Suleiman Mountain Range. This rocky terrain was once the bed of the ancient Tethys Sea. Locked away in this rock are secrets of ancient marine life and death. In 1978, a team of fossil hunters from Michigan set to work. Paleontologists are time travelers. They visit the ancient past by digging into the earth. Each layer of rock is like a time capsule, recording major events in the planet's history. Asteroids, natural disasters, climate change. It's all recorded in layers of rock, planet Earth's DNA. A team member cracks open a rock. Inside is a fossil, unlike anything they've seen before. This fossil sets one man on a voyage of discovery. The expedition leader was Philip Gingrich. In the University of Michigan vaults, he examines his amazing find. It's the partial skull of a mammal that lived 50 million years ago. In 1978, Gingrich couldn't work out which family of animals it belonged to.
When we found it, when we cleaned it, I really wasn't sure what it is. I was a specialist of land mammals. And it didn't look like anything I knew.
Gingrich commissioned experts in mammal anatomy to reconstruct its skull.
Gives you an idea of what the whole skull might have looked like. This is real and this is reconstructed, but it's reconstructed following the plan of a typical mammal.
Later digs uncover more crucial pieces of the skeletal jigsaw. Finally, this enigmatic animal comes to life.
I think it would have 4 limbs. I expect probably it had short hair, and they still have hooves. If we think it's a land animal, we'd expect it to look wolf-like.
But Gingrich still couldn't identify which order of animals it belongs to. Then he spots a tiny, S-shaped bone in the ear region. He finds out that this bone is known as a sigmoid process, and it's unique to one order of animals that today lives in the water. Gingrich finally realized what this creature is.
It's something primitive, it's something transitional, but nonetheless, with the sigmoid process, a primitive whale.
This can only mean one thing. The modern whale began life as a land animal. To find out how a land animal evolved into the modern whale, we must return to ancient Pakistan. This is the ground the creature walked on 50 million years ago. The world then is a hotter place. In the region that is now Pakistan, higher temperatures likely created an arid environment. The whale's ancient ancestor, named Pachycetus, faces a survival crisis. It's the shape, size, and weight of a modern wolf. It lives on a diet of plants and small animals. But climate change is wiping out his food supplies. He needs to find a new food source, and quickly. The ancient whale takes its first tentative steps into water. It's an extraordinary gamble. What rewards did the waters hold for Pachycetus? The answer lies in the earth itself. "50 million years ago, the land masses of planet Earth drift further apart. This creates new ocean currents. These currents convey warm water and air from the equator to the polar regions. Warmer poles mean a warmer planet. Temperatures can boost photosynthesis, producing an abundance of marine life. Pachycetus finds a banquet of food in these shallow waters.
I think they probably started as scavengers, running along a strand line, feeding on dead fish that washed up on the shore. And once you're in the water feeding on dying fish, it's a logical step to try to catch other fish.
Just as Pakicetus solves one crisis, food, it faces another. Predators. To swim, Pakicetus has to paddle like a dog. It's a poor design, making him a slow and clumsy swimmer. $50 million years ago, Pakicetus disappears from the fossil record. The next mystery is, what happened after Pakicetus? How did this land animal evolve to become king of the oceans? $50 million years ago, the whale ancestor, a land mammal named Pakicetus, disappears from the fossil record. In 1994, 16 years after Philip Gingrich discovered the remains of Pakicetus, one of his former students makes the trip to the same region of Pakistan. Hans Fewison is seeking ancient land animals. His quest will pay off beyond his wildest hopes. In rock dating back 49 million years, he discovers the bones of an unknown creature.
The first day we found a hind limb. The next day we found some vertebrae and some ribs. And the third day we finally found the skull. And I still didn't know what it was.
Bafflingly, this creature appears to have legs like a land animal, but feet like waders.
I got very frustrated with the fossil having this beautiful skeleton and not knowing which animal this was.
Then he spots a bone unique to one order of animals living today.
And then it struck me, this is an ear bone, and it's the ear bone of a whale. That finally made the penny drop. And I realized that now we finally found this amazing skeleton. This transitional whale, a whale with legs. It struck me that we caught evolution in the act here.
This is why Pakicetus disappeared. It had simply evolved into a new species. Poor swimming skills made Pakicetus vulnerable, so it adapts in 3 key ways to swim better. His tail develops muscles and flattens like that of an otter. His back legs shorten and widen to act like flippers. He becomes more streamlined. Fewison names this new species Ambulocetus natan, which means the walking and swimming whale. Sometime in the ancient past, a whale ancestor evolved the skills to live permanently in the oceans. Thewissen's next quest is to find out if Ambulocetus is the ancient whale that adapted to live in the seas full-time. If a land animal drinks seawater, it can be lethal. To live in the ocean, Ambulocetus would need to adapt to cope with salt water. This ancient whale's kidney isn't preserved, but could the answer to the riddle lie elsewhere?
When you're studying teeth, you really get a good idea of lots of different aspects of the life of the animal, such as its diet, where they were living in water, on land, and which waters they were drinking.
Thewissen expects the teeth to show Ambulocetus lived in the ocean. But the results are a surprise. They reveal that Ambulocetus drank fresh water. It had to stay close to rivers and lakes. This whale ancestor still lives primarily on land.
We were surprised because modern whales can drink seawater. Their ancestors were land mammals and therefore freshwater drinkers. So somewhere that transition had to happen, moving from fresh to sea.
But it hadn't happened 49 million years ago. And this raises an intriguing question. What prevents Ambulocetus from fulfilling the whale's destiny of life in the ocean? "50 million years ago, the whale is a wolf-like land creature that hunts in shallow waters. 1 million years later, it evolves 3 key features to swim better: a stronger tail, wider rear legs, and a more streamlined body. Despite being more aquatic than its predecessor, tests show that Ambulocetus, or the walking and swimming whale, lived mostly on land. To find out why, Thewissen returns to the skeleton. It's a complete Ambulocetus based on the one he found, and it gives away a surprising secret. This species has a large head and body, but relatively small hind legs. This can mean only one thing.
I think in water, Ambulocetus wasn't a very strong swimmer. It certainly couldn't pursue fish because the fish would be much faster than it. We think that it was a predator. It probably hang out in shallow water, sort of hidden, and waited for prey to come up to it and then would lunge to catch them.
49 million years ago, this poor swimmer faces grave danger, hunting even in shallow seawater.
If you look at the shallow marine fauna of that time, there are lots of big predators, such as big sharks, much bigger than the whales. They would certainly have been eaten and would have competition from crocodiles and sharks if they were hunting prey.
was it safer on land?
I think Ambliocetus would have been pretty clumsy on land. It would have been similar to a sea lion or maybe a crocodile. They would have been slow, lumbering, and mostly with their bellies on the ground as they were resting on land.
Poor in both land and marine habitats. 49 million years ago, Ambulocetus vanishes from the fossil record. The mystery of whale evolution deepens. When and how did the ancient whale evolve to live full-time in salt water? What is the secret to its transformation from clumsy land animal to master of the high seas? In 1994, Philip Gingrich from Michigan returns to the Suliman mountain range in Pakistan. It was here, 16 years earlier, he unearthed the oldest whale ancestor. His quest now is to find the first ancient whale that lived permanently in the sea.
They're extraterrestrial in the sense that they left the Earth, they left the land, and live in the sea today, which is a little like outer space, really. And the change to be able to live there is big.
The question is, can he now hook the biggest fish of all, the first fully aquatic whale? The rock here once formed the bed of the ancient Tethys Sea. The region is rich in ancient marine fossils, but remote. They must complete the journey on foot and camp. They set to work using only tools they can carry in a backpack: hammers, trowels, and brushes. The team discovers the skeleton of another ancient whale. The question is, could this species be the elusive missing link that cut its ties with freshwater? Back at the University of Michigan, they set to work, separating clean bone from mineral. Tests on the mineral rock reveal this creature lived 46 million years ago, 3 million years after Ambulocetus. This was a poor swimmer, struggling to escape predators or to hunt. This species has evolved a series of adaptations to swim better. He has a shorter, more powerful neck, better for diving. His rear legs widen and become more flipper-like. His tail develops muscles. However, the teeth of this ancient whale reveal something far more significant. Just 4 million years after the whale ancestor entered fresh water, this whale lives permanently in the sea. The secret to its success and the survival of the entire whale species comes down to a tiny but ingenious device inside its trademark ear. Paleontologist Philip Gingrich has unearthed a whale that lived 46 million years ago. He names it Rhodocetus. It appears to be the missing link between the wolf-like ancient whale and modern whales. Inside Rhodocetus is the key to an age-old mystery. How did the ancient whale, a land animal, adapt to survive in the ocean? There are few clues in its skeleton. It's 3 meters long and similar to Ambulocetus, the ancestor that 3 million years earlier had only been able to drink fresh water. Now this new species lives in the oceans and radiates throughout the globe. How has it adapted to this salty new world? And why don't vicious marine predators wipe it out? This becomes one of the single greatest mysteries of whale evolution. To understand Rhodocetus, we must first understand the world it lives in. 46 million years ago, India is separate from the landmass of Eurasia. The Tethys Sea lies between. Over tens of millions of years, India moves closer to Eurasia. As the Tethys Sea narrows, it becomes more shallow. Now, the climate plays a role.
In a shallow sea is highly productive because you've got a lot of light coming in, you have a lot of microorganisms processing the nutrients, and there's a lot there for fish to feed on. And of course, if there are a lot of fish, there's something there for mammals to go in and feed on.
For species quick enough to exploit it, the Tethys Sea is a marine Garden of Eden. Rhodocetus feels an irresistible evolutionary pull into the sea. The reward is straightforward: more food. Evolution modifies an existing organ to process salt water. His kidneys filter out the salt from the seawater, which he then excretes through his urine. Rhodocetus finds the subterranean world brimful in life. But not all of it is dinner. Fearsome predators stalk the Tethys Sea. For sharks and crocodiles, ancient whales have proven easy meat in the past. To survive, Rhodocetus must find a way to escape predators. The key to how this ancient whale survives in the ocean is hidden inside its most distinctive feature, the ear. Professor Fred Spoor studies a vital organ situated inside the inner ear of just about every creature. Called the organ of balance, it is key to the survival of Rhodocetus.
The organ of balance inside the inner ear is an absolutely vital, a key organ to function for any animal, whether you're a fish or a frog or a whale. It's an organ.
The organ of balance consists of 3 canals at right angles, filled with fluid. The fluid moves when the head moves. Nerve cells register these fluid movements and send signals to the brain. The brain instantly decodes these signals and adjusts our balance so we don't fall over. However, acrobatic behavior causes the liquid in our inner ear to slosh about. sending scrambled messages to the brain. This causes dizziness. The inner ear controls balance. But how did it tilt the balance of survival in favor of the ancient whale? Spohr finds the answer when he compares this human ear to that of the whale.
If we now, for comparison, actually look at the inner ear of a whale that has also been enlarged 12 times, then we can see that there's not that much overall difference in size, even though whales are, of course, much larger than humans are. However, the enormous difference is that the bit that deals with balance, here and here, is enormously reduced in the whale.
The whale's inner ear is so small that the liquid inside barely moves. This allows them to turn and twist at high speed without getting disorientated. Some 45 million years ago, the ancient whale's organ of balance was shrinking. And for good reason. It makes him agile enough to outmaneuver predators. Rhodoccetus survives and continues to evolve. But its descendants are about to face dramatic climate change and a terrifying new predator. Egypt, the Western Desert. 150 kilometers southwest of Cairo. These parched sands harbor secrets more ancient than the pyramids. Philip Gingrich has been excavating this site since 1983. In that time, he's unearthed 400 giant whale skeletons. These ancient whales are so large, they're named Basilosaurus, which means king lizard. But what are these whales doing in the desert?
Of course, the whales didn't really live in the desert. This was all a shallow sea before, and one that was full of sunlight, clear water, teeming with life, including archaic fossil whales. It's an 18-meter long, 50-foot long whale that you simply can't miss. Being so large, there's no doubt that Basilosaurus was the top carnivore, the top predator in this ecosystem. The equivalent, if you will, of T-Rex farther back in the past.
39 million years ago, this is the bed of the ancient Tethys Sea. By now, Basilosaurus thrives in oceans and seas all over the globe. Especially in the food-rich waters of the Tethys Sea. Basilosaurus has evolved a set of impressive tools for hunting. Exceptional eyesight, improved underwater hearing. It evolves its long, thin body shape to hunt in shallow waters, and from its terrestrial past, it retains two useless remnants.
The most interesting thing about Basilosaurus is the retention of hind limbs with all the bones right down to the tips of the toes. So they are a vestige of a former life on land.
Basilosaurus weighs in at a massive 6,300 kilos. Its change in size turns it from the hunted into the hunter. Now the tables are turned on an old foe. The shark. Sharing the waters of the Tethys Sea with Basilosaurus is a smaller, more vulnerable whale species. The Dorudon whale most resembles a modern dolphin. It has a powerful vertebral column and short, flipper-shaped forelimbs. And like the modern dolphin, it has a tail fluke. However, at just 5 meters long, it's much smaller than Basilosaurus.
There's even some evidence that Basilosaurus preyed on young, if not adult, Dorudon.
One theory is that to protect themselves from predators, Dorudon whales swim in pods. Only one of these two species will survive to become ancestor to the modern whale. But which will it be? The small, hunted Dorudon? Or its massive predator, Basilosaurus? Whale evolution spawns its next great unexpected twist. That 36 million years ago, the mighty Basilosaurus dies out. The question is, why? Gingrich has been scratching away at this conundrum for many years. The clues to the mystery lie beneath the sands of the Western Desert. Gingrich believes that Basilosaurus evolved its eel-like body to hunt in shallow waters. Its body shape is perfect for hunting in bays like this one. But is it a victim of its own adaptation? 35 million years ago, planet Earth is changing dramatically. Oceans continue to cool. Antarctica has split from South America and develops a permanent ice cap. Water that once flowed down into the oceans remains frozen at the poles. This causes a dramatic drop in global sea levels. Shallow coastal waters disappear, forcing Basilosaurus to hunt in deeper waters. Its eel-like body struggles in this deeper water. It lacks the power to dive.
Maybe it's only good for living in surface water. Maybe once you need to dive to get food, it wasn't so good anymore.
Short and muscular, the Dorudon has no such problems. This is the whale species left to inherit the Earth.
I would think that the success of Dorudon depended on its conservative body proportions. It's the one that succeeded, ultimately.
Dorudon survives, but the future of the whale species is in grave danger. Later, ancient whales face what many consider the most terrifying predator in history. A predator so big that each one of its teeth is the size of a man's hand. A further dramatic twist in the journey of the modern whale takes place 30 million years ago. In the cooler seas of the mid-Atlantic, the ancient whale is 5 meters long and dwarfed by a terrifying new predator. Monster sharks. Weighing in at 40,000 kilos and over 16 meters in length, the Megalodon shark's mouth is so large, a human could stand upright inside it. Even whales aren't safe from such a fearsome predator. Megalodon stops dead in his tracks. Unwittingly, ancient whales have stumbled upon a surefire way for their species to flourish for millions of years. To escape, they've headed away from the equator towards the new, chillier polar seas. Thanks to their warm blood, they can handle the cold water. But their predator can't. Sharks are cold-blooded. Their body temperature is the same as the waters in which they live. In colder water, their bodies can shut down.
Megalodon was tied to a warmer sea and didn't survive this new cold world.
These polar waters are safe from Megalodon and rich in food supplies. But the whale's problems are far from over. Visibility in these deep polar waters is poor. Somehow they must find a way to catch prey they can't see. The ancient whale must develop the most sophisticated marine tools in the natural world. Evolution arms predatory toothed whales with a high-tech device to hunt: sonar. They emit a focused beam of high-frequency clicks. The sound bounces off any object in its path. The whale can decode the returning echo and determine the size, shape, and speed of the object. Known as echolocation, the whale uses this to pinpoint and then swoop on shoals of fish. But how do they adapt to hunt in deeper waters? Whales can control the flow of blood to their hearts and brains. As a result, they don't suffer a lack of oxygen on deep dives. Modern sperm whales can dive over a mile down and stay below for 2 hours. Baleen whales evolve a digestive system to suit seasonal migrations. They can build up enough blubber to go without food for several weeks. This leaves them free to engage in typical mammal behavior, like mating, socializing, and showing off. Especially the most expressive member of the whale family, dolphins.
They're big-brained. Dolphins and porpoises are big-brained relative to their body size. They're very personable. If you ever meet them face to face, you have a sense that there's a sentient being there that reminds us of ourselves, I think.
Today, there are over 80 whale species. The largest is the blue whale. It has a heart the size of a Volkswagen Beetle and a tongue the size and weight of an African elephant. other whales have evolved incredible survival skills. The grey whale can swim 20,000 kilometers in an annual migration. Orcas can reach speeds of 55 kilometers per hour. And bowhead whales can live for over 200 years. The journey the whale has made to get this far is truly amazing. From its wolf-like ancestor, it struggles between land and water before finally adapting to the ocean.
It's like the Rosetta Stone for evolution. A lot of textbooks use the whale as their example for evolution because it's now so well documented.
I like it because it's big, and I like it because it's backwards.